complete antenna design process involves antenna modeling, simulation, fabrication, and measurement. Antenna measurement techniques refers to the testing of antennas to ensure that the antenna meets the targeted specification. Most of the time, measured results are used to verify the performance of an antenna. Note that sometimes large discrepancies between the simulated and measured results is due to poor measurement technique instead of fabrication process. In this session, we will look into antenna measurement, a topic in BEE 4433 Antenna Theory and Propagation. Parameters that we look into when measuring an antenna includes the space quantities, which are antenna's radiation pattern, consisting of antenna gain and efficiency and its polarization, while the circuit quantities involve the measurement of impedance, voltage standing wave ratio, and bandwidth. The process of antenna measurement begins with a good measurement setup. Measuring an antenna involves the transmitting unit that consists of a broadband antenna and a signal generator, and the receiving unit that consists of the antenna to be measured, which is normally termed as antenna under test, a positioning system, and a spectrum analyzer for space quantities measurement, or a network analyzer for circuit quantities measurement. Antenna operates steadily in its far-field region. These two units must be separated to comply with the far-field radiation range. Also, the measuring equipment must be placed at the appropriate height as to avoid the ground reflection errors. To measure the gain of the antenna, a reference antenna with known gain must be utilized. The radiation pattern is measured using Friis transformation equation as shown here. In logarithmic value, the gain of the test antenna is equal to the resulting of the gain of the standard antenna and the power of the received test antenna over the standard antenna and the reflection coefficient of the test antenna over the standard antenna. Note that for broadband measurements, the frequency transmitted must be varied, which means that the antenna measurement process are repeated with different transmitting frequency. Next is the measurement of the polarization of the antenna. In general, there are two techniques to measure the radiation polarization. Polarization pattern method, in which the antenna under test is at the transmitting part of the measurement setup. The receiver antenna must be a linearly polarized antenna and rotated in the x-axis. The received power is then plotted and measured. The second technique is the rotating source method. Here, the antenna under test is positioned at the receiving part, while the transmitter is a linearly polarized antenna which rotates continuously in the vertical plane. Finally is the impedance measurement. The measurement is done using a network analyzer. An important measure before the measurement is to calibrate the analyzer at 50 ohm. This is a crucial step as to eliminate the effect of the cables in the open circuit load and closed circuit load. The impedance measurement results can be represented in three formats, which are the Smith chart, reflection coefficient response graph, and voltage standing wave response. The impedance of an antenna can be represented in complex number, which carries the information of resistance properties and reactance properties. Positive reactance implies an inductive response, while negative reactance implies capacitive response. The far-field measurement can be performed in indoor and outdoor range. In general, there are two types of far-field antenna range, which are the reflection and the free space range. In the reflection range, a constructive interference between direct rays from the transmitting antenna and the specular reflection from the ground are created in the region of the antenna under test. In the free space range, the reflections from the grounds are minimized. There are three types of free space range: elevated range, slant range, and compact range. Elevated range are usually designed to operate mostly over smooth terrain. The antenna are mounted on towers and on roof of adjacent buildings. In the ground refraction range, the specular reflection from the ground is used to obtain a uniform phase and amplitude distribution over the antenna under test. A slant range is one in which the source antenna is located close to the ground and the antenna under test is mounted over a tower. Note that antenna measurement require that the antenna under test be illuminated in a uniform plane wave. This requirement is achieved in the far field range, which in many cases dictates large distance. A compact range creates a plane wave field at distance considerably shorter than those needed under conventional far field criteria. The required compact range usually so short that the implementation can be accomplished indoors. In a compact range, a uniform plane wave is generated by a large parabolic reflector. This is typically done in an anechoic chamber. Several types of chambers are available for antenna measurement, which are fully anechoic and semi-anechoic chamber. The dimension of a conventional test range can be reduced by making the measurement in the near field of the antenna under test, and then using analytical method to transform the measured near field data to compute the far field radiation characteristics. Such techniques are usually used to measure patterns and gain. The near field measured data, amplitude and phase distribution is acquired by using a probe to scan the field over a pre-selected geometrical surface, which may be a plane, a cylinder, or a sphere. The measured data is then transformed to the far field using analytical method. In the planar scanning technique, a probe antenna is moved in a plane situated in front of the antenna under test, and the received signal, amplitude and phase is recorded. In the cylindrical scanning technique, the antenna under test is rotated around z-axis of an XYZ coordinate system, while the probe is moved on a cylindrical surface at various heights relative to the XY plane. And in spherical scanning technique, the antenna under test is rotated around the z-axis. The probe is moved on a circular track. Today, we had gone through a complete cycle of antenna design process involving antenna modeling, simulation, fabrication, and the recent antenna measurement technique. In the coming session, we will go through the second part of BEE 4433, which is radio propagation.